Hello friends, welcome to my channel. Let's have a look at problem 1991. Find the middle index in array. In this video, we're going to share a treatment based on partial sum. So this treatment is the same as problem 2587. First, I'll read through the problem statement. Then we quickly look at the example and analysis. And finally, we explain the code. First, the problem statement. So given a zero-indexed integer array called nums, we want to find the leftmost middle index. So here, the middle index is an index where the sum to the left of this index equals to the sum to the right of this index. So if the index is 0, it means that the left set sum is 0. So similarly, if the mid index equals the length minus 1, then the right set sum is considered to be 0. So we would like to find and return the leftmost middle index that satisfies the condition. So otherwise, we return -1 if there's no such index. So here are several examples. So for example, in example 3, so there's no such index, so we return -1. So we can look at example 1. So in this example, so if we look at index 3, so to the left, so the sum is 4, and to the right, the sum is also 4, right? So the return for this problem is 3. So before we look at the problem the analysis, let's also look at the constraints. First, the length of this list is in between 1 and 100, which is not very large. So secondly, the elements in the list are also bounded by a small number, that is 1000 in absolute value. So with that said, we are ready to do the treatment or analysis. So here we want to solve this problem using the same method for problem 2587. So here we are going to use partial sum. So you can see a prefix sum or suffix sum sometimes. So here we use both partial sum from the left and from the right. So in other words, both prefix sum or suffix sum. So here we're going to look at the example 1 and the example, right? So at index 0, so we know the left sum is 0. But if we compute all this number together, we are going to get the right sum, that is 14. So similarly, at this index, you get left sum is 2, and the right sum is 11, so and so on. So at index 3, we first find equality. So both the two numbers, or the two sums, to the left and to the right, equals 4. So therefore, we return 3 for this example. So with that said, I guess it's routine to write the code for this problem. So here first, I'm going to get the length of this list. Let's call it n. So this is just for convenience. And then I'm going to set a left array and a right array. So initially all zeros in the containers. So then we want to find the prefix sums and suffix sums. So here, let me write like this. So left I, so is the sum, left sum up to, let's see, before I, right? In other words, not included. So once we realize this, so we can set at the left quickly. So similarly, we can set right. So we are going to use a for loop for I in range. So here we can start from 1 and ending at n-1. So here the left I equals left I minus 1, then plus nums I minus 1. So here I minus 1 because the sum is before index I. So this way we set down the left, right? Now let's look at the right. So for I in range, So we are going to start from n minus 2, and then the step is 1, -1, and we are ending at 0. So then we write this, write I equals write I plus 1, and num I plus 1. So that is after index I, right? So we have write I plus 1 here. So once we set the left and the right, so next we just want to check equality, right? Then we just do this. So for I in range m, right? Then we are going to check if left I equals right I. If so, we're going to return this I. Otherwise, after this for loop, so we're going to return -1, which means no such index. So this piece of code forms a solution format for this problem. So this is an easy problem as marked by LeetCode. So let's do a test. Yeah, it passes the first example. Now let's check with this example, because this returns -1. Yeah, it passes this one. Now let's look at the generic case. Yeah, it passes all the generic cases. So for the purpose of visualization or easy understanding, so actually we can print out the left, the right to examine, right? Oh, this is for this example. Now let's look at this one, right? Yeah, you can compare with the left and the right here. So here at index 3 we have 4 and 4, so we return index 3. So with that said, I guess that's about it for this specific problem. So you are welcome to check out other videos in my channel, so or find other problems which can be partial sums or prefix sum or suffix sum get involved. So with that said, that's it for this video. Thank you.